Welcome to a new test and teardown video. This time they actually call this a multimeter. Multi is for voltage and current, but it will also measure DC and AC voltage and current as far as I understand. So there's this dial down here where you change between DC and AC. The text is very hard to read. My light here is really powerful, and I need to have exactly the right angle. I don't know exactly how old this is. I got some numbers down there. This module was actually manufactured from 1933 and up to the 1960s. So that is a huge span. But by the look of this, it was really used. Look at all the scratches and stuff. I tried to clean it a little bit. We got some air holes. There's also a lot of air holes here. I see a lot of power resistors in here, but of course we're going to go and open it. Maybe that will be calibration screws you can access. Well, and it's quite heavy. So this is early bakelite material. What I see here is that will be off. And then we go to voltage, 600 volts. So this is the fun thing. 600 volts is full range, right? But look, the meter only goes to 3.0, so you will just have to double this. That is funny. Normally you will see, I don't know, 246 or something like that as well on another scale, if it can do something with 6. And look at that. So that is the 300 and 150 full range. Oh, now you need to do a little bit of math here, but I think most people would be able to do that. It's just a little bit funny. So this is definitely an old model, early model multimeter. Let's test how it works first, and then we're gonna open and see what happens. Let's just first try the 600 volts. And of course I just give it 600 volts and this is what it reads. So the 600 volts is not full scale. And in case you don't believe me, of course I just give it 600 volts, right? Just happen to own one of these fantastic thingies that can make all the voltages you can imagine, right? But anyway, so that was 600 volts. How about we crank it down to 300 volts, and then, so that is 300 volts. So it's definitely reading way too little in the voltages. So what is the next? 150. So that would be 150. And again, it just read way too little. So okay, there's definitely room for improvement. How about the amps? 150. I should be a little bit careful what I do here, because this thing can do like 1100 volts. So, scary. This is 0.3 amp full range, and again it reads 0.3. What are we doing? Okay, so that will be the black scale because I am in DC mode. So it is definitely reading way too little because that is 100 milliamps. So yeah, or you could just learn yourself to read the AC volts, but that's not how it works, right? Oh, look at that. This meter got 3 milliamps full range. I gotta try that. So let's go to fine and then dial the current down. That is quite interesting. So the next one is that one is 60. So now I got 30. So that is actually all right. No, it should be half. So that is not right. So that was my 30 milliamps. So let's go down to, what is this one? This is 15. And I got 10. So again. And then go fine again. Let's go all the way down to 3 milliamps. Yeah. There's definitely something to adjust and calibrate, but I will let the next happy owner play with the adjustments. I just really want to see what is inside this brick. That is actually quite impressive. So that will be, oh, they made it so this isolation material is not going to get lost, but I only see 2 sense resistors. What exactly? Ah, that is the contact. Duk, 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 duk. This is a heavy duty. And the click feel is really nice. Can you hear it? So that's probably a ball in here that goes around, goes up, yeah. That's actually what it is. I don't know if I'm able to get further in here. Maybe it's possible to take out these 2 halves. But where are the screws for that? Ooh, I see some screws down there as well. And that will be probably one of the screws. Do you think I can put this back together? Oh, here we got a screw hidden in there. Ooh, that is difficult. To be able to pull the front off, I needed to remove the knob. Look at the way they milled this. So there's no way the knob is gonna be the wrong place. That is really neat. So I think I am in. And what do you smell? It's more or less what I wanted to say. Yabba dabba doo. We got a lot of funny components and resistors, and what is that? Another? What the? It is just full of all sorts of fantastic. I did not expect it to be this complex. Wow. So that will also be some different resistors and stuff. And what is in here? That is probably a selenium diode of some sort, right? Because see, this is the AC or DC switch, and this is connected to all this stuff. Wow. And that stuff is also connected to this. Is definitely a very early age rectifier diode of some fascinating stuff in there. Whoa. And I'm not going to open this and break the seal, because the seal, they soldered this or glued this. But it is absolutely amazing. All we have to do to make this accurate again is to loosen this screw and remove this is the magnetic short, and then we'll get some more gain on the meter. That is that simple. And this trick, everybody copied that trick. A lot of funny components and stuff. I think I'm gonna put this back together again. It was very funny to see all those. Oh, wow, this got to be a very early model of the multavi 2 204904. What exactly does that mean? If anybody knows the age of this, please comment. I would love to know more about an accurate age. Thank you very much for watching again. I just couldn't let it go. When I was assembling this, I was looking a little bit more at this screw. So now I gave it 30 volts and I am now in the 30 volt range. So I did lose this screw, so I can adjust this magnetic short just to show you how it works. So if I move it this way, I will short the air gap, right? See? And now the meter goes down a little bit. And if I move it to the other side, it is really, really difficult to move this thing. Yeah, see? I open the air gap and then the magnet in here gets stronger. But it's not going all the way to 30. So there's definitely a resistor somewhere we need to change and then get too much. And then again, we can crank down the adjustment here. So that is the problem. The magnet has maybe lost its value a little bit, or maybe there's another resistor we need to find and adjust, but I don't have the schematic, but I guess it's possible to find that. So I will just put this nicely back.